Okay, guys, we're getting ready to move on to our next topic. We're going to talk about heat and phase changes. So, we're going to be dealing with things going from how much heat is required to take a solid phase change, liquid phase change to a gas, or vice versa. Remember, MCAT allowed us to heat within the same state or phase, but now we're going to go from one phase to another one. Most important thing you got to remember is let's get all our data and units that we need. We know we're dealing with water, so I'm going to get all the constants for water. I'm going to insert a text box right here. Okay, we're going to try. There we go. I'm going to paste everything here. Looks a little jumbled, so we're going to make it look clear for you. Okay, we're going to set that right there so we can get it out the way. Get rid of that. Heat of fusion of water. How much heat is required to take the water right here from solid phase to this guy right here. This is the melting phase. How much heat is required to go from here to here. And then you know your next one's going to be specific heat of ice, specific heat of water. That's how much we're going to use to heat it up right here, right? And then specific heat of steam, how much it takes to heat the steam up. Heat of fusion, this really should be heat of evaporation right here. And this is heat of fusion right here. Okay? Heat of fusion is heat of evaporation is how much heat is it required to vaporize right there. That's what all that means. I know that's a lot of junk, but it's going to make sense in just a second. First thing we want to do is let's go ahead and do a nice little equation here. I'm going to go use an input here because it's a little easier to clear instead of my crazy handwriting. So what we're going to do is we need to find the total heat. Happen to have it already created over here, which I'm glad I did because it's going to help you see it better. Remember, the most important thing is Q equals MCAT plus M times delta HF, which is the heat of fusion. This is how much heat is required to go from solid at 0 degrees Celsius to get water at 0 degrees Celsius. Then we're going to heat that up to 100 degrees, change to gas, and then we're going to heat it up to 120 degrees. So one best way to do this is take them one piece at a time. So what I'm going to do is I'm going to go ahead and give you the whole equation so you can see what's going on. All right, here we go. Let's draw another text box. Okay, being a little lazy this morning, but that's okay. It's going to help you see it a little better. And if you notice here, I already got the cookbook. Now we're going to plug in some numbers here. We know we have get my hand in the pen. I have Q equals, right? Jump up here. Let's see how much mass we've got. We know we've got 40 grams. So the first thing we're going to do is convert that to what? Kilograms, right? So that tells me I have 0.04 times specific heat of ice, which is 2090 times, be very careful here, change in heat. You're trying to change in temperature. You're trying to get to zero, but you got to do a minus. Sorry, you got to do a minus what? That's a minus. I think I've got too much junk going on. Got a little headache this morning. You got a minus 10 degrees, 15 degrees Celsius. So that way, when you do this, that's going to become a plus. Now, we've heated the water up 15 degrees. It's now at 0 degrees Celsius. Now we got to convert that ice into water, which means we're going to use M right here, delta HF. Once again, the mass is 0.04 because we've converted, times the specific heat of fusion of water. Specific heat, sorry, that's wrong. The heat of fusion for water, which is right here. Notice that's in joules per kilogram, so we're okay. So that should be 334,000, right, times the mass. So that should give us exactly how many joules we need. Now we add water. Now we got to continue. Let's jump down here. Now we want to add what? Now we got to heat that water up to 0 degrees Celsius. Once again, to 100 degrees Celsius. So once again, you know you're going to use MCAT. Your mass is 0.04. What's the specific heat of water? It's 4180. I'm trying to go from 0 degrees to 100. So my difference is going to be 100. Remember, it's T final minus T initial. And now we're sitting at water at 100 degrees. Now we got to convert that to gas. And our gas is going to use the heat of vaporization of steam of water, which is 2,257,000 kilojoules per kilogram, which we have 0.040. Where are these numbers coming from? Don't forget, you have the green sheet. I've even made sure I've gone back and included it onto your onto the Dropbox, so that way you can go look at the chart. Except for it's not green, nice and handy dandy right there. Everything specific is right here. Even if you continue to the back page, it's got specific heats, and it has all your heat of fusions and your heat of vaporizations right here. So everything should look good right there. Okay, back to our problem. Boom. Now we're sitting at what? Gas, right? This guy right here just converted to gas at 100 degrees Celsius. Now we're going to take that 100 degree, that 40, our gas is a steam, 0.04 kilograms of steam. Now we need the specific heat of steam, which is 2090. And what's our change? We're trying to go from, oops, sorry, let's erase that a second. Okay, we're trying to get to, what was the problem? The original problem says what temperature we're trying to get to, 120. So that means I'm gonna come down here. I know my final temperature is 120 minus 0, right? So we add all that together, and that should give us a final answer of about 2, got a little drunk, 0.33 joules, right? Or we also equate that to be, well, I'm about to break my own rule here. So let's come down here and let's make that equal to 122.03 kilojoules. Got it? That's a little messy, but I posted a nice little solution on Edmodo where all this typed out and written out. Let me see if I can give you a nice pretty copy of it right now from this page right here. Give me a second. Just a second, we're trying to copy over that solution for you so that way you don't have to fight it. You have it nice and pretty. Let me pause for a second while I get that ready. Okay guys, there's the nice pretty solution. You should see, remember, you gotta take the phase changes. First step was what? Heat the water to 0 degrees Celsius. Next step was heat the ice up to 0 degrees Celsius. Next step was what? Convert the ice to water. Next step was heat the water up to gas to steam at 100 degrees Celsius. Then we converted the water to steam. Start over. That made no sense. First, we took the ice, heated up to at 15 degrees Celsius, minus 15 degrees Celsius, heated up to water at 0 degrees Celsius. Then we converted the ice at 0 degrees Celsius to water at 0 degrees Celsius. Then we heated the water up to 100 degrees. Then we converted the water to steam. Then we heated steam at 100 degrees Celsius. Then we heated the steam up all the way up to 115 degrees Celsius. And that's your total heat. Sounds like a winner. Thanks.